The topic of the video is the relationship between differential scattering cross section and scattering amplitude. The incident free particles wave function is taken as a plane wave like this. As the velocity operator in quantum mechanics is v hat is equals to p hat divided by m, where p is the momentum operator, which we can write as minus I h cut into del operator. So by knowing the eigenvalue equation for the velocity operator, we can actually write the velocity of the particles as h cut k naught divided by m. Also, the number of incident particles per unit volume can be actually found by taking the modulus of psi incident square. So if you want to find the flux of incident particles, we can actually multiply the number of particles per unit volume into the number of particles which are leaving some kind of unit length per unit time. So if you do so, we get the flux of incident particles, which you can abbreviate as which we can denote as a j sub inc, as modulus a square into h cut k naught divided by m. So as the scattering wave function for particles scattered along the direction theta phi can be expressed in terms of the scattering amplitude f theta phi as this. The flux of the particles scattered along theta phi direction can be written as j sub sc is equals to modulus a square into f theta phi square into 1 by r square into hk divided by m, just similar way that we got this j incident. But for the theta phi direction, the number of particles crossing this area dA in unit time is n theta phi. So the scattered flux should be delta n divided by dA, and as this solid angle d omega is dA by r square, we can even express dA as d omega into r square. Therefore our scattered flux which we got this way, in terms of scattering amplitude this way, should be equal to this quantity in terms of delta n. So we can express the ratio delta n theta phi and d omega as this quantity here. So now, as the definition of differential scattering cross section is d sigma by d omega, which is delta n theta phi divided by d omega into j incident. So if you actually write down the expressions for both delta n divided by d omega as the numerator and j incident as the denominator here, we can see the cancellation of modulus a square, m and h cut. So finally we get this expression for d sigma by d omega in terms of the scattering amplitude. And this is the relationship between differential scattering cross section and scattering amplitude. That's it in this video, and thanks for watching.